Alright, here in this video we're going to talk about solving quadratic equations using what we call the square root method. Now, I mentioned in the last video I did, which was using the factoring method to solve quadratic equations, that there are a number of different methods we can use to solve quadratic equations. We have the factoring method, we have the square root method that we're going to talk about here. We also have the quadratic formula, which we'll do in another video. The square root method, just like the factoring method, it doesn't always work, right? The quadratic equation has to be in a certain form in order to be able to use this square root method. But if the quadratic equation is in that form, the square root method is like the easiest way to solve the quadratic equation. But like I said, it doesn't always work, right? You have to have a very specific type of quadratic equation in order to be able to solve it this way. What that quadratic equation has to look like is this, right? If we have x squared equal to c, where c is a constant, just some real number. So your equation doesn't have to be in that form, but it has to be able to be put into that form where you just get x squared equal to a number. If you're able to get the equation into that form, basically what you do is you take the square root on both sides of the equation, and your solutions are x equals the square root of c, and this x equals the negative square root of c. Right, so when you solve using that square root method, you actually get the two solutions by getting the positive and the negative square root of that number. Right, so that's what we call the square root method. And this one, let me actually change this to a different number just so we can kind of see a little more clearly maybe how this works. All right, so for our first example, let's say we have the equation x squared equals 9. Okay, so it's in this form, right? X squared is equal to a number, and therefore I can solve using this square root method. All I do is square root both sides of the equation. The square root of x squared, remember, the root and the exponent are inverses of each other. They're opposites of each other. As long as I'm taking the second root, that's going to cancel out the second power. Right? So the root cancels out the second power, and I get x. Right? Equals, and then I have to do the square root of 9 on the other side. Remember, I'm allowed to do a square root on both sides of the equation as long as I do it on both sides to keep the equation balanced. Right? Just like I can add 2 to both sides of the equation, or divide both sides by 3. I can do a square root on both sides as long as I do it to both sides. Right? So the square root of x squared gives me x. The square root of 9 is going to be 3. Right? But when you use this square root method, and this is the biggest mistake people make, is just neglecting to do this, you actually get two answers. You get x equals 3, you get x equals negative 3. Right? Because there are two numbers. If I go back to my original equation, x squared equals 9, there are two different numbers I can plug in for x that will give me 9. Right? Obviously 3 squared, 3 times 3 is going to equal 9. Right? The square root of 9 gives me 3. But if I do negative 3 times negative 3, since I'm squaring it, it's going to cancel out those negatives and still give me that positive 9. Alright, so that's the key thing. When you are using this square root method, you have to remember that you have to do the positive and the negative of the square root of whatever number's on the other side of the equation. Alright, so it's a real important thing. And like I said, it's something that a lot of times people tend to forget about or just leave out. Alright, so two solutions to this quadratic equation, and like I said in the video that I did on the factoring method, most of the time for quadratic equations you do end up with two solutions, right? And no matter which method you use, you should end up with those two solutions. With the square root method, that's how we get the 2, is by doing the positive and negative square root. Right? Just let me put up here like a side example. Like I said, let's say example C here. I'm going to do that before I do example B. Let's say we have an equation like this. X squared minus 5 equals 0. All right, so if I have an equation that looks like that, x squared minus 5 equals 0, it's not exactly in this form, right, of x squared equals c, but I can put it into that form, right? Anytime I have just an x squared and I have a number, let me actually change this a little bit just to show you how it can get a little more complicated. Let's say I had 2x squared minus 10 equals 0. Right? Anytime I have a quadratic equation that doesn't have that x term in it, right, that middle term, like we have an x squared, we have a constant, but we don't have an x to the first power. Anytime I have a quadratic equation that doesn't have that x to the first power, I can use this square root method. Right? So that's something you can be aware of. That's your clue that you can use this method, which, like I said, when you can use this method, it's the easiest way to do it. It's pretty quick, right? So in this case, the 2x squared minus 10 equals 0 is not x squared equals c, but if I move a couple things around, I can put it into that form pretty easily, right? If I add the 10 to both sides, I would have 2x squared equals 10. If I divide both sides by 2, I would have x squared equals 5. Right? So with a couple steps of basic algebra here, I get into this form x squared equals c, and then once I get it in that form, I square root both sides, so I get x equals positive and negative square root of 5. Right, and I cannot simplify the square root of 5, so I just leave it as plus or minus square root of 5. And that plus or minus in front indicates the two answers, right? The positive square root of 5 and the negative square root of 5. So that covers my two solutions to that equation. Right, so to use this square root method, your equation doesn't have to look like x squared equals 9 from the start. It can look something like this, 2x squared minus 10 equals 0. As long as you can rearrange it to get it into the form of x squared equals 5, then you do the square root on both sides, and you've got your solutions at that point. All right, so like I said, this is the easiest method to use to solve quadratic equations. The downside of it is it doesn't always work, right? So I'm going to erase this one here and put up another one just to show you an example of when you can't use this method. All right, so let's say I had example D here, x squared minus 5x plus 2 equals 0. All right, so let's say I had an equation like that. All right, well, can I get that equation into the form x squared equals c? I can't, right? I have the x squared here. If I subtract that 2, if I try to add that 5x to the other side, if I have that x on the other side of the equation, when I try to take the square root on both sides, that x on the other side of the equation is then going to be underneath the square root, and that's not going to give me what x is equal to, right? I need x equal to a number, not x equal to some other thing with an x still in it, right? That doesn't really tell me what the solution is. All right, so anytime you have that x term there, that minus 5x, or anything in here with an x to the first power, this square root method is not going to work for you, and that's when you'll have to use one of the other methods, right? If I took this out, then I can maybe use the square root method, right? So if you have that x term, like what we just had up there, and you can't use this square root method, that's when you try to use the factoring method, or if that doesn't work, you try to use the quadratic formula to solve it. All right, and the quadratic formula, I'll do another video where we talk about that formula. All right, so yeah, square root method, really simple, really quick and easy to do, but it only works for certain types of quadratic equations, right? When we can get x squared equal to a number. Or for this type of equation here, where I don't have x squared equal to a number, but I have something squared equal to a number, and that something involves the x inside of parentheses. So something in that form, I can still use this square root method. It's just going to look a little bit different. All right, so for this one here, what I'm going to end up doing is, since I have this squared equal to 5, I need to cancel out that second power, and the way you cancel out a second power is by taking a square root. Right, the second root cancels out the second power. And that's true for any root. If I had something to the third power, I would take the third root to cancel out the third power. If I had the seventh power, I'd take the seventh root to cancel out the seventh power. All right, so when I do the square root on the left side, that cancels out the second power, and I get x minus 4, right, freed from that second power that I had. Right, so that's why we do the square root here, because it cancels out the second power and gets the stuff in parentheses out of the parentheses. Right, so I get x minus 4 equals, and then remember, when you're doing the square root method, you have to put that plus or minus on the square root on the other side of the equation. Right, so x minus 4 equals plus or minus square root of 5. Right, just like we had up here when we did the square root of this, we had positive 3 and negative 3. Here we have positive square root of 5 and negative square root of 5. Right, and once again, I can't take the square root of 5, so I just leave it inside the square root. Right, we want to give exact answers here. Don't put square root of 5 into your calculator and write down the decimal for it. Because once you start writing down the decimal, you have to round it off at a certain point, right? Square root of 5 is an irrational number. You cannot express it concisely with a decimal or a fraction or anything. The most exact way to write that number is to call it square root of 5. Right? So to give it an exact answer, we just leave it in the square root. All right, so x minus 4 equals plus or minus square root of 5. I still need now to solve the equation for x, right? I'm not done yet because I don't have x equals. I have x minus 4 equals. So what I need to do then, since it's x minus 4, I need to add 4 to the other side of the equation, right? That cancels out the 4 over here, so I get x equals, and now here's the trick to this. This is not really a trick, it's just something to watch out for. All right, I have 4, and I have that plus or minus square root of 5. You cannot add that 4 to the 5, right? The 5 is inside the square root, the 4 is not. You cannot just combine a square root with something that's not in the square root by addition or subtraction. That doesn't work. So the way I would write this would be just positive 4 plus or minus the square root of 5. That's the most concise way to write the solutions to that equation. All right, so once again, we have two solutions here. We have 4 plus the square root of 5, and we have 4 minus the square root of 5. If I were to take those two numbers and plug them back into this original equation for x, it would check out, and I would see that when I do all that work on the left side, it's going to equal 5. All right. So that is the square root method. Again, it's a pretty simple method to use, but it only works in certain types of quadratic equations. And if it doesn't work, that's when you have to use one of the other methods. That's why it's really important to know all the different methods that you can use. You know, for this one up here, this x squared equals 9, like we could have done that one by factoring as well. We could have done that one using the quadratic formula, but using the square root method is the easiest way to do it. Just square root both sides, x equals 3, x equals -3, you're done. Right? So important to know the methods. It's important to know when to use them and when you can use them and when you can't. Right? You don't want to try to use the square root method on an equation where it's not going to work because it's not going to come out correctly. All right? So that is, again, the square root method.